Hi everyone, I am Dr. R. Soumya, Assistant Professor, Department of Electronics and Communication Engineering. Today we are going to see the subject Electron Devices and Circuit. Under this, here we are going to see the topic PN junction diode. So semiconductor is the basic one. A semiconductor is a material which has the electrical conductivity to a degree between that of metal and that of an insulator. Semiconductors are the foundation of modern electronics, including transistor, solar cells, light emitting diodes, and digital and analog integrated circuits. So what is diode? Diode is di plus ode. Di means two and ode means electrode. So physical contact of two electrodes is known as diode, and its important function is alternative current to direct current. The semiconductor is divided into two types, intrinsic semiconductor and extrinsic semiconductor. So let us see about the intrinsic semiconductor. An intrinsic semiconductor is one which is the pure enough that impurities do not appreciably affect the electrical behavior. In this case, all carriers are generated due to thermally or optically excited electrons from the full valence band into the empty conduction band. Thus, equal number of electrons and holes are present in the intrinsic semiconductor. Next one, eccentric semiconductor. An extrinsic semiconductor is one that has been doped with impurities to modify the number and type of the free charge carriers. An extrinsic semiconductor is a semiconductor that has been doped, that is, into which a doping agent has been introduced, giving it different electrical property than the intrinsic semiconductor. Doping involves adding dopant atoms to an intrinsic semiconductor, which changes the electron and hole carrier concentration of the semiconductor at thermal equilibrium. The extrinsic semiconductor is again divided into two types. One is N-type semiconductor and another one is P-type semiconductor. Let us see about the N-type semiconductor. Extrinsic semiconductor with large electron concentration than hole concentration are known as the N-type semiconductor. In N-type semiconductor, electrons are the majority carriers and holes are the minority carriers. N-type semiconductors are created by doping an intrinsic semiconductor with donor impurities. P-type semiconductor. And opposed to N-type semiconductor, P-type semiconductor have a large hole concentration than the electron concentration. In P-type semiconductor, holes are majority carriers and the electrons are the minority carriers. In P-type semiconductors are created by doping an intrinsic semiconductor with acceptor impurities. So PN junction. So the N-type and P-type semiconductor materials are joined together. This is shown in figure. This is the symbol of the PN junction diode. So there are two biasing, forward bias and reverse bias. Forward bias, when the positive terminal of the battery is connected to the N-type and P-type and negative terminal of the N-type of PN junction diode, that is known as the forward bias. So this is the VI characteristics. At this voltage the potential barrier is overcome and the current through the junction start increases rapidly, that is the cut-in voltage. 0.3 is for the germanium and 0.7 for the silicon. Next one, reverse bias condition. The negative terminal of the battery is connected to the P-type and positive terminal of the N-type is connected to the PN junction, that is known as the reverse bias. So VI characteristics. Thank you.